Good morning and welcome to our live coverage of Vulcan Centaur's Certification Flight 2 mission, also known as Cert-2 mission from Space Coast, that is from the pad Space Launch Complex 41 at Cape Canaveral Space Force Station in Florida. We hope you all are doing fine and excited about the upcoming final certification flight for United Launch Alliance Vulcan rocket. Hello, my name is Deepto Mitra, performing the commentary for today's mission launch. Before moving to the mission details, firstly on behalf of AstroYonder's team, we express our heartfelt gratitude to everyone for being a part of today's launch. We really appreciate you being here. A big thanks to our amazing YouTube community for being here today as we provide detailed coverage of space launches, complete with extensive statistics and thorough insights. We are super excited bringing you the live coverage of the second of two test flights required for ULA's, that is United Launch Alliance, certification process with the US Space Force. Also, the CERT-2 mission. The certification 2 mission includes an inert payload and demonstrations associated with future Centaur V technologies. Just a heads up, I will be providing real-time in-flight updates post-launch, so request you to listen closely. And also I'm managing the launch coverages all by myself. So if we face any technical issues, please stay tuned. Will do my best to give you the best possible viewing experience. Today's launch marks United Launch Alliance 163rd overall launch and the 5th launch of this year. Right now we are waiting for a Vulcan's liftoff at 6 a.m. Eastern Time from Cape Canaveral for a southeasterly launch for Vulcan Certification 2 mission with an inert payload on board. The Vulcan rocket will launch the inert payload with a mass of 1,500 kilograms to a heliocentric orbit. While weather conditions are 80% favorable, with 20% probability of violation, with minor concerns of cumulus cloud rule. Now let's move on and learn a little bit about the Vulcan rocket. At the base of the rocket, we have Vulcan booster, which is powered by dual BE4 engines. For additional thrust required during the liftoff, we have solid rocket boosters, also known as SRBs. In today's rocket configuration, we have two solid rocket boosters. On the top of the booster, we have the interstage adapter, and above that we have the center upper stage, which is powered by two RL10C engines producing 23,825 pounds of thrust. And finally, on top of everything, we have the payload fairings, which will be encapsulating an inert payload for today's mission. The payload fairing today is of 15.5 meter, that is 51 feet tall, and 5.4 meter diameter, also termed as standard payload fairing. The fairing comes in three variations: standard, long, and multi-manifest long. We will discuss all of them in a little more details to have a better understanding. Before moving on, would like to welcome both of our moderators right on time. They made it finally. Fairmate, thanks for tuning in. Welcome, and we hope that you are doing well. Also would like to welcome our another moderator here, Pop Tripika. Thanks for joining us, Pop Tripika. Hope you also are doing well. So you have an hour before you have to go to work. Hopefully you will be able to have that launch from now. If it will be the launch will be happening in just 30 minutes from now, I guess. 10 minutes is left for the webcast to begin, so at least you will be getting to see that launch. Yes, the last lunar mission, the last launch of the Vulcan, but that was the first maiden flight for the Vulcan. And on the certification 1 mission was that Astrobotics Peregrine lunar lander mission, which failed, but the Vulcan rocket made it through. It passed its first certification mission that time. Now let's move on and talk about today's rocket. Today's Vulcan configuration is VC2S. On your screen you can see this naming convention, which is having a meaning as well, just like Atlas 5 rockets. Now here V stands for Vulcan, of course, C stands for Centaur, 2 denotes the number of solid rocket boosters, and S denotes the fairing size, which is a standard one for today. This configuration can vary depending on customer's need, varying from 0 to 4 and 6 solid rocket booster, and the payload fairing in 2 sizes. The most powerful configuration of Vulcan would be VC6L. So in that case, you can understand from this naming convention as VC, Vulcan Centaur it will be, and 6 is the number of solid rocket boosters, and L stands for the payload fairing, which will be having the longer variation. Now, for example, Peregrine flew on a VC2S similar to today's configuration, and the Dream Chaser will fly on VC4L. So in that case, for the Dream Chaser, we will have 4 solid rocket boosters and the long form of the fairing. Now please consider giving this video a like. It really helps YouTube's algorithm bring in more space lovers and rocket fans to discover this stream, helping us to build a community with amazing space enthusiasts like you. We would be super grateful for your kindness and support. Now let's start from the top of the rocket. We have the payload fairing. The spacecraft is enclosed in a 5.4 meter, that is 17.7 foot diameter payload fairing, which is composite structure made from a vented aluminum honeycomb core and graphite epoxy face sheets. This bisector two-piece payload fairing surrounds the spacecraft entirety, and the payload attach fitting, that is short of PAF, made from a similar composite material which connects the spacecraft to the second stage and the payload fairing. The payload fairing separates using a debris-free system for both horizontal and vertical separation, featuring spring packs and a frangible joint assembly. The payload fairing comes in 2 configurations. First is 15.5 meter, which is 51 foot standard version, and another is 21.3 meter, that is 70 foot long version. So in that naming convention, as I discussed before, that S stands for standard and L stands for long version. Now with multi-manifest version of the payload fairing, 2 or more spacecrafts are integrated on a launch vehicle using available performance and volume margin that would otherwise go unused, optimizing mass to orbit and enabling missions. On this particular mission, Beyond Gravity built and supplied the payload fairings. Also, they provided the interstage adapter and payload attachment fittings. Now Vulcan's second stage, also referred as the upper stage, will be powered by 2 RL-10C engines known for their reliability, with nearly 400 successful flights and close to 700 in-space firings. Built by Aerojet Rocketdyne, these engines run on high-energy liquid hydrogen. The RL-10 is equipped with an precision control system and the ability to restart, ensuring precise payload placement into orbit. Now, as we came to the booster, but in between we have that interstage adapter, same as SpaceX interstage. They are composite structures that connect the main stage of a rocket with its upper stage. Now here next we have the booster, which measures 17.7 foot, that is 5.4 meter in diameter, and 109.2 feet, that is 33.3 meter in length. Its tanks are made of orthogrid aluminum barrels with spun-formed aluminum domes and features a common bulkhead. Fueled by liquefied natural gas and methane, the booster is powered by 2 BE4 engines. Next we have the solid rocket boosters. The Vulcan rocket can integrate up to 6 graphite epoxy motor, that is short of GEM 63XL solid rocket boosters, which are built by Northrop Grumman. For today's mission, 2 solid rocket boosters are being used. These boosters are made from graphite epoxy composite, which is a throttle profile built into the propellant grain. Each GEM 63XL SRB provides an extra 4,59,600 pounds of thrust, which is equivalent to nearly 2,100 kilonewton of thrust at liftoff, which is the additional power required at liftoff. The Centaur avionics system handles the guidance, flight control, and vehicle sequencing during both the booster and Centaur stages of the flight. Now we have just 1 minute. Let's just wrap up this. Next, we have the main engine. At the bottom, we have the main engine, a pair of BE4 engines manufactured by Blue Origin. These engines will provide the booster propulsion, each generating 5,50,000 pounds of thrust at sea level. The BE4 is a staged combustion engine which is having a single oxygen-rich preburner and a single turbine driving both the fuel and oxygen pumps. These engines will subsequently reduce the dependency on modern Russian kerosene-fueled RD-180 engines, which are used in Atlas V. Now I guess it's time for the webcast. Let me just check it. Yes, it's time for the webcast. So let's move on. We will discuss rest of the things later on. If you are feeling we are adding value to your viewing experience, consider giving this video a like, which really helps YouTube's algorithm to bring in more space, fans like you, and people to find out this stream. Also consider subscribing to us as we strive hard to bring streams filled with stats and details, and that will inspire us to work more hard.
Linhoff, a systems engineering leader at ULA and your host for live coverage of today's Vulcan launch. I'm joining you from ULA's Advanced Spaceflight Operations Center at Cape Canaveral Space Force Station in Florida. Thanks for getting up early for the second launch of ULA's Vulcan rocket. Today's flight is dubbed Cert-2, signifying the second certification mission for the new Vulcan rocket. The first certification flight successfully lifted off earlier this year. The Vulcan rocket will continue ULA's legacy of support to our U.S. government, civil, and commercial customers. And with today's flight, we'll move a step closer to certifying Vulcan for government missions. We'll learn more about certification throughout the broadcast. On board the Vulcan rocket is an inert payload along with several tests and demonstrations for future Vulcan capability. Liftoff is scheduled for 6 a.m. Eastern at the top of our 3-hour launch window. In addition to watching our webcast, you can also follow live mission progress at ulalaunch.com. About 40 minutes ago, the count entered a 60-minute planned hold. We have 2 planned holds in our launch count, which give our team additional time to resolve any issues prior to entering the terminal count. At this time, the team is not working any issues and we are proceeding towards an on-time liftoff. Live coverage this morning will continue through second main engine cutoff, which occurs at about 35 minutes after liftoff. To kick us off, let's learn more about today's flight from ULA's President and CEO, Tory Bruno.
we are coming up on a very important and exciting launch. This is our second flight of Vulcan, which is also our second certification mission. This is really important to both our company and especially our customers because this flight is necessary for us to begin flying national security space missions. And there are already a pair of these in the pipeline that are vitally important to our country. Our original plan had been to fly Sierra Space's Dream Chaser vehicle, a really cool mission that we have been supporting them in for a number of years now. However, they're just not quite ready in this time frame, and we have to proceed in order to clear the way for national security. Don't worry about Dream Chaser, we will circle back and fly them as soon as they're ready. In the meantime, we will be flying a mass simulator, sometimes called an Inert payload, and fly a very similar trajectory to what we flew on Cert-1. Because we have that Inert payload, we are also free to add a number of experiments and technology demonstrations that will help us with our enhanced upper stage plans in the future. This will allow us to have more performance, to do more agile trajectories and insertions, especially for our national security space customer, as well as extend the duration of that upper stage, which is essential for a whole number of things that we will do both commercially and to contend with our country's challenges in space that are being presented by adversaries like China, and allow us to provide that kind of support that will keep space a peaceful environment and one in which our country feels secure. So this mission is coming up soon. It's going to be very exciting, and then it opens the door for whole new missions for Vulcan in the future. Thank you.
As we look at the Vulcan rocket on the pad, we see the American flag across the inner stage with the ULA and Vulcan logos on the payload fairing. Though it's hard to see now with the booster filled with cryogenic propellants, the Vulcan logo is also wrapped around the first stage. And a portion of the booster includes spray-on foam insulation or SOFI to improve thermal protection and enhance performance. Let's learn more about this innovative new rocket.
Now I have just muted the uh, stream audio because it contains some copyrighted tracks which can have content ID claims on our channel. Although what they will be saying I already have said you. You can see the same animation here showing the solid rocket booster, then now the center upper stage which is powered by dual RL-10C engines, and the payload fairing which will be having an inert payload as Tori mentioned, which is a mass simulator, as because we didn't got to have the Dream Chaser payload today. After the success of today's flight, United Launch Alliance with the Vulcan can now proceed to launch other United States Force or national security payloads. And when the time comes, they will be launching the Sierra Space Dream Chaser CRS SNC-1 mission. Now today's Inert payload, which is a dummy payload. It will be placed in a heliocentric orbit. So now let's just this clip to get over. You can see now on your screen how the rocket is being transported to the pad.
As we approach the terminal count pole, let's check in with Arlena Moses to share today's Space Launch Delta 45 weather forecast.
Thanks, Andrea. We just heard from our lead launch weather officer stating weather is great for our launch this morning. And if we take a look at radar behind us, we can see we've had just enough dry air move in over the past 24 hours that has pushed most of our storms and showers that are happening overnight down to our south. The little bit of activity we have up across to our east over the Atlantic Ocean remains a little too shallow and a little too far to our east to be a concern here over the next couple minutes. Our main area of concern here is within this white ring, which represents 10 nautical miles. So if we go here and take a look at our forecast here, we're going to only be looking at a POV of down to just 5% with no significant launch weather concerns tracking. Winds are going to remain from the east, this light breeze about 10 to 15 knots, with temperatures around 80 degrees this morning. Weather looks great for the launch. And back to you, Andrea.
Come, Andrea, respond. Where Andrea went away. The Vulcan rocket combines the best of today's Atlas V and the Delta IV Heavy into a single core rocket to support US national security, commercial, and civil launch needs. Today, the VC4S, the 2S variant which stands 202 feet tall and generates 2 million pounds of thrust. Now let's hear to the webcast. I guess Andrea came back. Well, thanks for confirming, Pop Topeka, that there is no issue on the stream. Now, just a second, when I was talking in between, Andrea was talking. Now I made the stream audio to turn on, she again went away. We are having approximately 9 minutes from liftoff. Right now on your screen, you can see the clock has been stuck to T minus 7 minutes. Well, there are some updates that launch conductor Dylan Rice has informed launch director.
This is Vulcan Mission Control at T minus 7 minutes and holding. You'll frequently see today that there's a VC2S for our configuration that we're flying. The V, the first in this configuration, stands for Vulcan. C, the second, is our Centaur upper stage. 2 indicates the number of solid rocket boosters, so for today that's 2. And then S is standard, and that is our payload fairing length.
That was a great update from Andrea. Anyway, now let me tell you the real update. The launch director Dylan Rice has informed launch director Eric Richards that the launch team will need a few extra minutes to complete preparations. So we will not be resuming the countdown for liftoff at the opening of the window, which is 6 a.m. Eastern Daytime. So a new target launch time will be provided, but for now it has not yet been set. Right now we were in the T minus 7 minutes and holding period. This is where the countdown enters the planned 60-minute built-in hold, designed to give a bit of margin to ensure that the team is ready for the terminal count and today's launch window. So within that holding only, we got this update that now they will be setting a new liftoff time. So we are awaiting for that. Any live update upcoming will be notified to you by me. Till then, enjoy the view of the rocket on the pad. Well, today's mission marks 163rd United Launch Alliance overall launch. This will be the fifth launch of United Launch Alliance this year.
This is Vulcan Mission Control at T minus 7 minutes and holding. The Vulcan launch vehicle experienced a data dropout, which caused the ground systems to stop propellant flow to the rocket. The team has configured the systems to resume flow, and we are working to establish a new T0 shortly.
I guess I am faster than them to provide the updates. Anyways, so Vulcan making its second flight for this year on its second certification Cert-2 mission. This will be the 85th orbital launch for United Launch Alliance, launching from Space Launch Complex 41. And this will be the 113th overall launch from this pad. Before we had United Launch Alliance Atlas V supporting USSF 51 mission on July 30th this year, marking the fourth launch for ULA this year. Also, ULA made 2 Atlas V launches.
This is Vulcan Mission Control at T minus 7 minutes and holding. Building on more than 130 years of combined Atlas and Delta launch experience, ULA's Vulcan rocket introduces a balance of new technologies and innovative features to ensure a reliable and accessible space launch service. Let's hear more about this incredible launch vehicle.
Well, guys, I'm sorry I can make this audio to play. Once again, I'm repeating that this contains some copyrighted tracks which are harmful for the channel. So enjoy the view. Although anything essential that should be mentioned to you will be notified by me. Now, I was mentioning that this year ULA had 4 launches prior to today's launch, with 2 Atlas 5 launches and 1 Delta 4 Heavy launch on its final flight, and Vulcan's first certification flight. Today, now we are awaiting for its second certification flight right now. Well, guys, uh, that's a update. But it's hard for me to even spell it. That today's launch window now extended for 3 hours until 9 a.m. Eastern Date Time. So reaching to the end of the launch window, which was started from 6 a.m. Eastern Date Time to 9 a.m. Eastern Date Time. Now I guess, not even I'm guessing, it is an update. They already mentioned it. Now Andreas will be coming and updating you guys with this same stuff. So let's just
LC, ALC. Go. Countdown clock has been reset with a new T0 of 10:30 Zulu. We are currently at L-29 and counting. Roger.
LC, RC. Go. The range has approved our new T0.
mobile pop Tripika. I'm looking
This
at
is
the
Vulcan Mission Control at T-minus 7 minutes and holding. A new T0 has been identified at 6:30 a.m. Eastern.
well. So if that's the update, then we are just 30 minutes away.
Fuel 2. Yeah, okay. You copy.
But their website mentioned about they rectified it.
Fuel 2, LC.
Launch director Eric Richards had instructed
And I just wanted to ensure you copied the transmission to re-perform the cylinder ramp-out cycle.
Affirmative.
Roger. Has gas, establish scan patterns 62 and 63.
Launch director Eric Richards has instructed the team to retarget today's launch for 6:30 a.m. Eastern Time. That is 10:30 UTC. You were right, Paprika, 10:30, but UTC. We are coordinating the time and resetting the L minus clock to align with the new target right now. And I am beating Andrea by giving updates. Actually, that's a secret. I'm stealing this from the website. The website gives the update a little bit earlier than Andrea. Anyways, meanwhile, we should be keeping an ear to the comms happening. Yes, Bob Trip. Sorry. Yes, we have made. I also
This
don't
is
want.
Vulcan Mission Control at T-minus 7 minutes and holding. Launching rockets takes the coordination of a team of experts. Let's hear from launch conductor Dylan Rice on what it's like to lead a team on launch day.
Well, again, there is a music. It started and I stopped it. Sorry. Well, yes, Famer, what I was saying that even I don't want to. I couldn't sleep again yesterday night for this launch. I'm right now just about to fall on my nose. Anyhow, I'm just making this stream, then I will be sleeping, so I don't want that delay. That's why I got a little bit shattered seeing that update on their website that they will be launching 3 hours later. Thank God, they made it only 30 minutes to delay. And Pop Pika, I guess, still you will be able to have the launch to witness. Now, okay, let's keep our finger crossed. Hopefully, no more issues will be coming. But I must say, whenever I'm preparing for these launches now for this channel as I'm working here, I saw that United Launch Alliance always give the most in-depth details for any launch they are targeting. You will be getting enough live updates directly from their comms on their website. You don't have to keep an ear to the webcast only. Moreover, you will be getting enough resources to prepare for any live stream or even for your academic reason to learn from them. So I really appreciate United Launch Alliance for their this initiative which they do for each of their launch. This is a Delta variant. I guess they will be showing the final flight for the Delta 4 Heavy as well. Right now on your screen, you are seeing the certification flight 1 for Vulcan. Well, the solid rocket boosters, which are graphite epoxy mortar, short of short for GEM 63XL solid rocket boosters.
This is Vulcan Mission Control at T-minus 7 minutes and holding. ULA builds Atlas and Vulcan rockets in a 1.6 million square foot facility in Decatur, Alabama. Here's a look inside.
This Andreas is coming and playing some videos and going away. Anyways, you have that view. Enjoy the view with Delta 4 Heavy. You can see on your screen. Meanwhile, let me just tell you some facts. So the solid rocket boosters are constructed out of graphite epoxy composite with the throttle profile designed into the propellant grain. The GEM solids supports the actually not supports, they supported the Delta 2 and Delta 4 rockets, and the GEM 63 variant flew on ULA's Atlas V rocket prior to the first Vulcan launch. These solid rocket boosters provide nearly 5,59,600 pounds of thrust, which is the peak vacuum thrust, and each solid rocket booster is of length 71.8 feet. And the nominal burn time for the solid rocket boosters are 90 seconds. Meanwhile, let me just tell you the update we are receiving right now. We are nearly 23 minutes away from the new launch time. Vulcan's propellant tanks are topped off at flight level right now. And let me just make you acquainted with the flight profile. At T-minus 4 minutes, not 4 minutes, at 4 seconds, the BE4 engine ignition will take place. At T0, we will have the liftoff. At about T plus 7 seconds, Vulcan will begin the pitch or yaw maneuver. At 1 minute and 9 seconds into the flight, the vehicle will reach the Mach 1. That is, then the vehicle will be supersonic. And following that, at T plus 1 minute and 16 seconds, the vehicle will pass through the maximum dynamic pressure on the vehicle, also known as max Q. The solid rocket boosters will be jettisoned at T plus 1 minute and 48 seconds into the flight. We have SECO for SpaceX launches, but here we have BECO, that is booster engine cutoff, that will happen at T plus 4 minutes and 59 seconds into the flight. The booster and the Centaur will separate from each other at T plus 5 minutes and 5 seconds. Centaur main engine start, that is MES1, event will take place at t plus 5 minutes and 15 seconds. The payload fairings will be jettisoned at t plus 5 minutes and 23 seconds. Then finally we will have the MECO 1 main engine cutoff for the Centaur at t plus 15 minutes and 55 seconds. At t plus 30 minutes and 53 seconds, we will have the Centaur's second main engine start, and the event is also known as MES-2. And the final milestone in the flight profile today, that will happen at t plus 34 minutes and 54 seconds. That is when the Centaur second main engine cutoff will take place, that is MECO 2.
C prop 1.
Go.
SGI charge to flight pressure.
Roger.
L minus 16 minutes.
This is Vulcan Mission Control at T-minus 7 minutes and holding. Earlier this week, the ULA team conducted an extensive practice ahead of today's launch attempt. We're looking at video of the wet dress rehearsal. The WDR is a full day of launch test. During the WDR, Vulcan's booster and Centaur stages are powered up. Avionics are tested and final preps to the ground systems are accomplished. Next, the rocket is loaded with methane, liquid oxygen, and liquid hydrogen. With the rocket fueled, the team proceeds into the terminal count, which includes pressurizing the rocket, arming various systems, and transitioning the rocket to internal power. The WDR count ends just seconds prior to T0. The rocket is then safed, the cryogenic propellants are drained.
PNE-1, initiate post-liftoff launch head umbilical purge autofile.
Roger.
So guys, it's me Deepto from AstroYonder team.
L minus 14 minutes.
Prop 1, perform G&G snuffer purge cycle test.
Roger.
In between right now as
Please, OSM1.
Go.
First step, 1040. Launch sequencer overrides established.
Roger.
LC, PNE2.
Go.
CUC airborne pre-chill is complete. Recorded time, 10:16:13. Zulu.
Recording 10:16:13. Zulu.
Good copy.
right now the vehicle system engineer is polling the Denver technical team comprised of specialists in the various hardware and technological disciplines on Vulcan. The experts have conducted evaluation of the rocket data and systems performance throughout the countdown. The results of this poll will be routed to the ULA Director of Engineering, who will then supply his readiness to launch when polled by ULA's launch director.
RC, verify solar radiation acceptable for launch.
Verified.
KNE-1, verify post-liftoff launch head umbilical purges configured for launch.
Verified.
LC Prop 1.
Go.
G&G Snapper Bird cycle test complete.
Roger.
LC flight control.
Go.
Launch on time verified.
Roger.
Minus 12 minutes.
RLM, verify red line monitor and event table in the correct configuration for terminal count.
Verified.
LC LOX 2.
Go.
Centaur LO2 at flight level.
Roger.
LC Fuel 2.
Go.
Centaur LH2 at flight level.
Roger. Terminal count briefing. If a condition exceeds a launch constraint anytime after the terminal count status check, the observer shall announce hold, hold, hold on channel 1, identify their station, and briefly state the reason for the hold.
So far, it seems like everything is nominal for the liftoff.
All communications switch to channel 1. All personnel and visitors remain in present position until launch. Maintain operational silence in the LCC.
All steps complete prior to the status check. LC switch ready.
We remain in the hold as we continue towards liftoff. In a few moments, launch conductor Dylan Rice will pull the launch team for the final go to pick up the count. 29 engineers and managers are pulled for system status and readiness to proceed. This is the final status check for all Vulcan vehicle systems, ground systems, and the U.S. Space Force Eastern Range. The vehicle system readiness poll includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as Dylan Rice performs the final polling.
Minus 10 minutes.
Status check to proceed with terminal count, Vulcan systems, propulsion.
Go.
Hydraulics.
Go.
Pneumatics. Go. LNG.
Go.
LO2.
Go.
Water.
Go.
Centaur systems, propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
Has gas.
Go.
Electrical systems, airborne. Go. Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
TCQ.
Go.
Off support.
Go.
COM.
Go.
Umbilicals.
Go.
ECS.
Go.
Redline monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range coordinator.
Go.
Launch director.
You have permission to launch.
Proceeding with the count. ALC, verify T0 is set for 1030 Zulu.
Verified.
Polling is
ABE, issue
complete
MRT.
and the team is go for launch. From T-minus 7 minutes until liftoff, you'll hear Dylan Rice and the team performing the final steps in the countdown procedure. Several critical activities occur in the final minutes before launch, including verifying fuel tank levels and pressures in the booster and Centaur and arming the flight termination system. At T-minus 1 minute, the range operations commander confirms the range is in a green condition for launch. At T-minus 25 seconds, you'll hear go Vulcan, go Centaur, go Cert-2. This is the final status check of the rocket and payload readiness. At T-minus 6 seconds, initiation of the Launchpad water deluge system occurs. At T-minus 3 minutes, the main engines ignite. Then after seeing Vulcan lift off from Slick 41, you'll begin hearing flight commentator Hannah Peters providing launch vehicle ascent data.
We just heard the Vulcan control team and the ULA leadership in Denver and Cape Canaveral have voiced readiness to proceed. The ULA launch director Eric Richards has given the final permission to launch. The pronouncement was made following the readiness poll of the launch team by launch conductor Dylan Rice, who verified all systems are go to resume the countdown. We are targeting a liftoff at 6:30 a.m. Eastern Daytime, 10:30 UTC. T-minus 8 minutes standing by to pick up the countdown clocks once again. The rocket and the pad systems are confirmed to be in the proper configuration for the terminal count. The final phase of today's countdown is now underway at Cape Canaveral Space Force Station for the second launch of the United Launch Alliance Vulcan Centaur rocket. The terminal count will prepare and pressurize and also will arm the launch vehicle for today's mission to deep space. T-minus 6 minutes and 26 seconds and counting. Red line monitor is observing more than 1,000 of parameters to ensure there are no violations to predetermined operating ranges through liftoff. This is the flight profile on your screen. Right now, this view you are watching is the full capacity of the Vulcan Centaur with 6 solid rocket boosters, and this one is for today with 2 solid rocket boosters. You saw the solid rocket boosters being jettisoned. Now coming up, it happened the BECO, that is booster engine cutoff and booster Centaur separation. Coming up will be the payload fairing, that it is, followed by MECO, the Centaur first main engine cutoff. Then it will be the Centaur second main engine start, MES2. And lastly, the MECO 2. The stream's audio feed is on, is a normal silence there in the COM. As they mentioned, operational silence it is.
$3:30.
Hydraulics at pre-launch.
This is Vulcan Mission Control at T-minus 3 minutes and 22 seconds. Following liftoff, viewers watching in Florida may be able to see Vulcan in flight as it heads east. To get a closer look at this map, check out ULA Launch on social media.
Right now we are less than 3 minutes from the liftoff. Meanwhile, Falcon 9 is undergoing the FAA investigation again. Hopefully, SpaceX will make it through until the European Space Agency's Hera mission.
T-minus 2 minutes. The launch vehicle, ground systems, and Eastern Range are go for launch. For those of you just joining us, I'm Andrea Lenhoff, your host for today's live coverage of ULA's second Vulcan rocket launch. At this time, the team is not working any issues, and we're proceeding towards an on-time liftoff at 6:30 a.m. Eastern.
Clocks have stopped at T-minus 1 minute, 51 seconds.
Now we are in a hold. The countdown sequence has stopped because a condition was found that need to be examined before we can continue. That's why on the top left on your screen you saw the countdown to fade away. At T-minus 2 minutes
LC, this is flight control.
Go.
Flight control is ready to reset the clock to T-minus 7 and holding.
Roger. ALC, reset the countdown clock to T-minus 7 minutes and holding.
Roger.
LC Peony 2.
Go, Penny 2.
Centaur LH2 and LO2 tank venting in progress.
Roger.
LC Peony 1.
Go.
Vulcan tank pressures are stable.
Roger.
LC countdown clock is reset to T-minus 7 minutes and holding.
Roger.
LC, this is flight control.
Go.
Step 50 SS VAPS and active SCS in pre-flight mode.
Roger.
Just before the reset of the
Data T0.
just before the newly adjusted T0 again to reset the clock and holding at T-minus 7 minutes. Previously, the Vulcan first stage and Centaur V upper stage switched from ground power to internal batteries for launch. And that time it was
SRB ignition disabled.
upon switching from the ground power
All
to
stations recycle systems back to T-minus 7 and holding configuration. Hold occurred at T-minus 1 minute, 51 seconds. Report status at completion. Airborne electrical LC.
Go ahead.
Transfer transmitter battery external.
Roger.
as I was mentioning that upon switching from the ground power to the internal batteries just before the launch, which happened previously in the previous launch timing. Now the clock has been reset again, once again. So upon that, the start command will be issued to the launch sequencer, and then the sequencer will perform the independent verification of the systems for the rest of the countdown. Which will control the detachment of umbilicals from the vehicle and release the rocket from the pad at liftoff. So these same incidents will be happening now upon resuming the clock for the liftoff. Right now we are still at hold.
LC Prop 1.
Go.
First step 260, substep Delta and Echo, Vulcan propulsion and hydraulic system stable.
Roger.
LC ECS.
Go.
Step 260, substep Oscar, ECS set point stable.
Roger.
LC SYS.
Go.
Step 260, substep Mike, GC3 ready.
Roger.
LC Fuel 2.
Go.
First substep Juliet, Centaur LH2 continuing topping.
Roger.
Right now, the ULA team are recycling the Vulcan rocket countdown to prepare for another opportunity to conduct the mission launch today. As mentioned before, we have an available window until 9 a.m. Eastern Daytime, that is 1 p.m. UTC or 13 hours UTC for the liftoff to occur. So now let's listen to the comms.
LC. Airborne electrical.
This LC.
Step 260, subset Papa, airborne electrical ready.
Roger.
LC Lux 1,
Go Lux 1.
Vulcan L2 continuing topping.
Roger.
LC, this flight control.
Go flight control.
Substep Lima, flight control ready.
Roger.
LC has gas.
Go has gas.
For substep India, has gas ready.
Roger.
As we watch the live view of the Vulcan and the pad Space Launch Complex 41, we from AstroYonder's team have an update to share with you guys that we have now our merch store online, so you can have a look there, and if you like anything, you can purchase them. That will support our overall infrastructure to provide you the better experience for the live stream.
Op 100, step 260, sub-step November, complete.
Roger.
This is Vulcan Mission Control at T-minus 7 minutes and holding. While we await a new T0, RS rocket ship, ULA's specially designed cargo ship, delivers our rockets to our launch sites in California and Florida. Let's take a look at this unique capability.
Once again, we are sorry for not having the audio feed over these video clips. As it contains copyrighted tracks which we are not allowed to use on our stream until we don't have permissions from them or the copyright to be bought. Meanwhile, just let me tell you that the BE4 engine fabrication is being done at Blue Origin, which is based at Kent, Washington. The solid rocket booster fabrication at Northrop Grumman, at Magna the booster fabrication and final assembly. Then the Centaur tank fabrication and the final assembly took place at Decatur, Alabama. Alabama, I think the pronunciation is that. The payload fairing also got fabricated at the same place by Beyond Gravity, as mentioned before. And the RL-10C engine fabrication at Aerojet Rocketdyne, which took place at West Palm Beach in Florida. Also, a point to be noted that the RL-10C engine today is having the variant of RL-10C-1-1A, which will be supporting today's mission. RL-10C is, you can say that it's a common nomenclature for the engine, but it has some kind of variations. We just got an update that the system recycle of the countdown has been completed. I guess they will be resuming the countdown now when they will be done showing this clip. We will get more update from them. I'm still keeping an eye on the live feed of their update. Once again, let me just repeat myself. The system recycle of the countdown now has been completed. This clip we are watching, I guess it is for the transportation of the CBC, that is the common booster core. Let's hear the feed now. We should be getting some call outs from the comms regarding the countdown. Meanwhile, just for an update, that we will be streaming the undocking and the splashdown of the Crew 8 mission, which is scheduled for October 7th, as well as the OneWeb Launch 20 mission from Vandenberg. So be sure to tune in. Although right now on our channel only the OneWeb Launch 20 mission is being scheduled, but we will be having the live stream for the Crew 8 undocking and splashdown scheduled by today's evening.
This is Vulcan Mission Control at T-minus 7 minutes and holding. As we await a new T0, let's check back in with Arlena Moses to get another weather update.
Thank you, Edra. Taking a look at radar here this morning, we've had a few more showers develop here across the Gulf Stream, which is located about 20 miles offshore, but they continue to be low enough topped that we're not expecting any significant launch weather concerns. Though, as we continue to push into the window, they will approach the coast. Generally, when we get within 10 nautical miles, which is that white circle that we look at, we have to see them get a little colder topped. A little taller tops, usually about in the 15, maybe 20,000 foot range. And right now, they're kind of below that, so not continuing to be a launch weather concern. So if we go to our forecast, still looking pretty similar for what we were seeing earlier this morning. Overall probability of violations, very low, 5%. Continuing with our breezy easterly winds with temperatures in the low 80s and no significant launch weather concerns. Back to you, Andrea.
Very nice view there on your screen. Quite a dramatic sky. And as mentioned before, the probability of violation was 20%, but right now it reduced to 5%, as you just heard from the weather officer. Right now we are awaiting for any update regarding the system recycle of the countdown, which has been completed, but we are not getting any update either on their website, neither on the live stream.
LCM1 AC.
Go AC.
I have a recommendation for you for R11 line item adjustment.
Proceed.
Okay, we want to take the following 8 line items from a value of 31.1 to 32. These line items are 188, 191, 194, 197, 207, 210, 213, 216.
All right, I copy line items 188, 191, 194, 197, 207, 210, 213, and 216. All those are currently set to a value of 31.1. The new value of 32 is the direction.
Affirmative.
RLM, LC?
RLM, go.
And did you copy the recommendation from the team?
Yes, I did, and ready to implement.
Roger, please put that in work and report when complete.
This is Vulcan Mission Control at T-minus 7 minutes and holding. As we look at this beautiful sunrise over Slick 41, we continue to wait on a new T0. Reminder that our launch window today extends to 9 a.m. Eastern. The team continues to work on a new T0, which we will share with you when it becomes available.
The United Launch Alliance teams are still evaluating a new liftoff time for today's Vulcan's second certification flight.
LCRLM. Go. Limits changed on 8 requested line items upward from 31.1 to 32.0.
Roger.
As now we are watching this mesmerizing view of the rocket on the pad. With nice view of the sky there. Let me just tell you some of the modification that has been done at the Cape Canaveral at the pad Space Launch Complex 41. So the ULA team upgraded the vertical integration facility, short for VIF platforms, decks and crane to accommodate all Atlas and Vulcan configurations. Modifications to Space Launch Complex 41 to accommodate Vulcan processing and launch comprises liquefied natural gas ground systems, increasing the fuel and oxidizers storage capacity.
LC1 AC.
Go.
Ready to provide you a recommendation.
LD net 1.
LD.
Proceed AC.
Okay, the team has reviewed the hold that was put into place and isolated that to the VCU line items. We have adjusted the 8 line items affected by this voltage concern.
And go ahead, LD.
LC, let's please coordinate and implement a new T0 of 11:25:0:00 Zulu.
Roger. RC, LC net 1.
RC, go ahead.
Please coordinate a new T0 of 112500 Zulu.
Roger.
ALC, please set the countdown clock for a new T0 of 112500 Zulu.
Roger, in work.
Well, the technical team has reviewed the issue and determined there is no other concerns with
And all
proceeding.
personnel on net 1, this is the LC. We're going to reestablish an L25 configuration and proceed again toward another terminal count run. PNE2, LC.
Good.
Initiate CUC airborne pre-chill.
Roger. LC, RC.
Go.
The range is approved our new T0 of 1125 Zulu.
Roger.
And LC, ALC, countdown clock has been set for new T0 of 1125. We're currently at L25 and counting.
Roger. LOX 2, LC.
LOX 2.
Perform Centaur LO2 fill and drain valve cycle test.
Roger.
So as I was mentioning, the technical team has reviewed the issue and determined that there is no other concern with proceeding towards another attempt. The red line limits will be adjusted. As you heard, the new launch time, the launch director Eric Richards has instructed the team to retarget today's launch for 7:25 a.m. Eastern Daytime, which is 12:24 hours UTC. We are coordinating that the time, and also the ULA team will be resetting the T- clock to align with the new target. Hopefully it will be reflected on the stream sooner. We are still on the hold period of T-7 minutes, although we are targeting for the liftoff time, which got newly adjusted for 7:25 a.m. Eastern Daytime, 11:25 UTC. And as I was mentioning, those modifications to Space Launch Complex at Cape Canaveral Space Force Station in Florida, made by ULA team, which also included increasing the acoustic water suppression system capacity. Also, the team upgraded the former solid rocket assembly facility, now known as Space Flight Processing Operational Operations Center, short for SPOC, to accommodate Vulcan launch platform, construction and storage. They also renovated the rail system from Space Launch Complex 41 to SPOC, that is the Space Flight Processing Operations Center.
Roger. Resume Centaur LO2 topping at flight level.
Roger.
This is Vulcan Mission Control at T-7 minutes and holding. ULA also launches Atlas rockets here in Cape Canaveral, Florida. Let's take a look around.
I have turned off the audio once again for the same reason as mentioned before. For the copyrighted tracks, you can enjoy the view. Let me just continue those last points of the modification which has been done by United Launch Alliance team here at Space Launch Complex 41. I was just mentioning that they renovated the rail system from Space Launch Complex 41 to the Space Flight Processing Operations Center to accommodate mobile launch platform. And overlapping Vulcan and Atlas launch campaigns. Additionally, they modernized for the overall pad for maximum efficiency and reliability. Now the ULA team will be performing the 7-minute terminal count once again to put the Vulcan and the pad systems in the correct configurations for the launch.
If the rocket is ready for flight and the weather is...
Well, they are not done yet. Also, one thing it is worth mentioning that the ULA teams are working on Vulcan so that they can make it reusable. So it will be coming as a competitor to SpaceX. Don't know about how frequent they will be able to launch, but they are trying. The ULA team is trying hard to make the Vulcan reusable. ULA in the very inception decided to develop the Vulcan Centaur back in 2014, I guess, for two main reasons. First was its commercial and civil customers who were heading to SpaceX for cheaper Falcon 9 reusable launch vehicle, leaving ULA increasingly reliant on US military and spy agency contracts only. And also for a second reason, that is Russia's annexation of Crimea in 2014, which highlighted the congressional discomfort with the Pentagon's reliance on Atlas V rocket, which used the made in Russia, which I mentioned before, the RD 180 engine.
Minus 16 minutes.
We are T minus 16 minutes away from
This is
liftoff.
Vulcan Mission Control at T minus 7 minutes and holding. As we move toward a target T0 of 7:25 a.m. Eastern for Cert-2, earlier this year we launched the inaugural flight of the Vulcan rocket. Let's take a look back on that spectacular flight.
During this first certification flight on January 8th of this year, Vulcan lifted off for the first time. The flight used the same configuration as of today, that is VC2S, with two solid rocket boosters and a standard payload fairing configuration. A 4-minute translunar injection burn followed by the payload separation made the Peregrine lander on the trajectory heading to the moon. 1 hour and 18 minutes into the flight, the Centaur upper stage fired for a third time, as it was intended for that flight profile, sending the lunar lander into a heliocentric orbit to test how it would behave in long missions, such as those required to send payloads to geostationary orbit. But a failure in Peregrine's propulsion system shortly after the separation prevented it from landing on the moon. But Astrobotic, the company supporting the Peregrine's lunar lander, said that the Vulcan Centaur rocket performed without any problem. So for that, the Cert-1, the certification first flight for the Vulcan, was a success. As we are here today for the second certification flight. I guess we are nearly T-minus 14 minutes.
13 minutes.
13 minutes away from liftoff.
Flight control, perform launch on time verification.
Roger.
OSM, place SRB ignition SNA switch in the enable position.
SRB ignition enabled.
Verify the FCO, ROC, and OSM hold fire switches are in the proceed position.
Ready to proceed.
RC, verify solar radiation acceptable for launch.
Verified.
NE1, verify post liftoff launch head umbilical purges configured for launch.
Verified.
Launch on time verified.
Roger.
Minus 12 minutes.
Terminal count briefing. If a condition exceeds a launch constraint anytime after the terminal count status check, the observer shall announce hold, hold, hold on channel 1, identify their station, and briefly state the reason for the hold. RLM, verify red line monitor and event table in the correct configuration for terminal count.
Verified.
LC LOX 2.
Go.
Centaur LO2 at flight level.
Roger.
LC Fuel 2.
Go.
Centaur LH2 at flight level.
Roger. LC switch is ready. All steps are complete prior to the status check.
Minus 11 minutes.
We remain in the hold as we continue towards liftoff. In a few moments, launch conductor Dylan Rice will pull the launch team for the final go to pick up the count. 29 engineers and managers are pulled for system status and readiness to proceed. This is the final status check for all Vulcan vehicle systems, ground systems, and the U.S. Space Force Eastern Range. The vehicle system readiness pull includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as Dylan Rice performs the final pulling.
Status check to proceed with terminal count, Vulcan systems, propulsion,
Go.
hydraulics,
Go.
pneumatics,
Go.
LNG,
Go.
LO2,
Go.
water,
Go.
Centaur systems, propulsion,
Go.
pneumatics,
Go.
LO2,
Go.
LH2,
Go.
has gas,
Go.
electrical systems, airborne,
Go.
ground,
Go.
facility,
Go.
RFFTS,
Go.
flight control,
Go.
CCQ,
Go.
op support,
Go.
comm,
Go.
umbilicals,
Go.
ECS,
Go.
redline monitor,
Go.
quality,
Go.
op safety manager,
Go.
ULA safety officer,
Go.
vehicle system engineer,
Go.
anomaly chief,
Go.
range coordinator,
Go.
launch director.
You have permission to launch.
As we just heard, it's a go for launch. The Vulcan control teams and the ULA leadership in Denver and Cape Canaveral provided their readiness to proceed. The ULA launch director, once again, Eric Richards, has given the final permissions to launch. Right now we are targeting a liftoff at 7:25 a.m. Eastern Daytime, 11:25 UTC.
Minus 25 seconds, you'll hear Go Vulcan, Go Centaur, Go Cert-2. This is the final status check of the rocket and payload readiness. At T minus 6 seconds, initiation of the Launchpad water deluge system occurs. At T minus 3 seconds, the main engines ignite. Then after seeing Vulcan lift off from Slick 41, you'll begin hearing flight commentator Hannah Peters providing launch vehicle ascent data.
On my mark, the time will be T minus 7 minutes and counting. 3, 2, 1, mark.
So we just came out of the hole of T minus, which was at T minus 7 minutes. Right now the clock has resumed. The final phase of today's countdown is now underway at Cape Canaveral Space Force Station for the second launch of United Launch Alliance Vulcan Centaur rocket. The terminal count will prepare, pressurize, and arm the launch vehicle for today's mission to deep space. Right now we are T minus 6 minutes and 13 seconds and counting. Red line monitor is still observing more than thousands of parameters to ensure there are no violations to predetermined operating ranges through liftoff. We are getting amazing views.
Securing Centaur LO2.
Securing Centaur LH2.
The Centaur V upper stage is undergoing final configuration for launch as the liquid hydrogen and liquid oxygen replenishment from the ground systems to the rocket are being secured. T minus 4 minutes and how much seconds? 55 seconds and counting. Topping of the LNG fuel supply and liquid oxygen to the Vulcan first stage is being terminated in anticipation of launch. Right now we are getting the close-up views of the BE4 engines. Pretty sure we will be getting amazing views from this vantage point. T-minus 4 minutes and 11 seconds and counting.
Ullage conditioning complete.
Pre-launch pressurization has started for the Centaur V upper stage. The liquid hydrogen and the liquid oxygen cryogenic propellants will be used by the dual RL-10 engines in burns to achieve a low Earth orbit and then accelerate the Centaur into the deep space. T-minus 3 minutes and 37 seconds and counting. The Vulcan first stage is pressurizing to flight level after closing the LNG and the liquid oxygen vent valves. The stage will fire its two PE4 engines at the bottom for 5 minutes to propel the vehicle out of Earth's atmosphere. Right now we are T-minus 3 minutes and 8 seconds and counting.
$249. FTS internal.
The acoustic sound water system at Space Launch Complex 41 is ready. The system will flow water at the rate of 7,300 gallons per second to dampen the sound intensity of the launch. Right now the Vulcan first stage and the Centaur upper stage are switching from ground power to internal batteries for launch, as I mentioned before. In the next few seconds, the start command will be issued to the launch sequencer. Followed that, the sequencer will perform independent verification of the systems for the rest of the countdown. Control the detachment of the umbilicals from the vehicle and release the rocket from the pad at liftoff.
$135. FTSR.
The flight software on the Vulcan has gone active as the vehicle's onboard guidance and navigation computer assume control. The rocket's ordnance
20.
controller, the vehicle's
SCS count started.
safety
115.
system and solid
CCS,
rocket booster
reduce CCS for
firing
launch.
chains
Roger.
have been armed.
T-minus 1 minute.
Rock, report range status.
Range green.
The main engine controller will switch to autonomous mode.
45.
Vulcan tanks at step 3.
Vehicle tanks will reach flight pressurization and computers will verify the engines are ready to start.
30.
BE4 start box go.
28.
Verify ECS reduced for launch.
Verified.
Status check.
Go Vulcan.
Go Centaur.
Go Cert-2.
15.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, We have engine ignition. 1. And liftoff of the United Launch Alliance Vulcan rocket, carrying ULA's legacy of reliability, orbital accuracy, and high energy performance.
Everything looking nominal. BE4 performing as expected. All temperatures and pressures looking good. Vehicle has begun its pitch and raw program. We have 2 good BE4s.
You are hearing Hannah Peters providing launch vehicle ascent data.
And we've ended the pitch program. Vulcan's now at 1.5 or 0.5 Mach.
We had a successful liftoff. Vulcan is ascending from Cape Canaveral on the power of its methane-fueled main engine and twin solid rocket boosters. The
BE4 is now throttling down in
southeasterly
preparation for
flight
SRB burnout.
path will take the Cert-2 mission to an initial parking orbit before embarking on
And
its
vehicle is past Mach 1. Vulcan is supersonic and maximum dynamic pressure.
interplanetary
Coming up on SRB
trajectory
burnout.
into deep space. We just heard that
And
the
we have
vehicle
indication of SRB burnout. Up next is SRB jettison.
We just heard that the vehicle went supersonic and reached the max Q.
Body rates continue to look nominal, trending towards 0.
T plus 2 minutes and 7 seconds. Solid rocket
BE4
boosters
is now throttling
burnout
down. And we have SRB jettison.
and jettison is confirmed. Both Northrop Grumman made
Vulcan is
JAM-63XL
19 miles in altitude.
We just
15
heard
miles
confirmation
downrange,
of
and
solid
have Vulcan
rocket
at
booster jettison.
2,400 miles per
We
hour.
have about 3 minutes until we reach our next mission event, booster engine cutoff.
The both JAM-63XL motors have successfully separated from the Vulcan first stage after completing their
From
job
RCS valve activation.
of providing nearly half of the energy at liftoff.
Body rates continue to look good.
The Vulcan continues to accelerate on its thrust from its BE-4 main engines and soon will transition to closed loop guidance to aim the
And we're
trajectory.
now just about 2 minutes to nominal BECO. And we've had RCS valve activation.
T plus 3 minutes and 24 seconds. The Vulcan rocket remains on course, flying down the
And
center
vehicles continuing down the range track.
of the range track to
Traveling
space.
currently at 4,600 miles per hour.
The main engines are firing as programmed, generating more than 1,000,000 pounds, that is 4.4 meganewtons of thrust. Right now you are seeing an animation of the flight.
Continue to have 2 good engines. Body rates trending towards 0. And we're now about 1 minute to nominal BECO.
1 minute to go from BECO.
Vulcan is now 1/4 of its liftoff weight. And Vulcan is now passing the Kármán line.
The main engine will soon step through throttling segments to maintain constant G acceleration limits in preparation for the conclusion of the first stage flight. The Centaur is also about to begin its cool-down sequence during the boost phase of flight in preparation for
And we started boost
RL-10
phase shield down on
ignition.
the second stage engine. And the BE4s are throttling to maintain a constant acceleration. And we've concluded our boost phase chill down. And PU has gone to open loop. And we have BECO, booster engine cutoff.
And there we go. We had BECO.
And we have Vulcan Centaur separation. And pre-start on LH2.
Vulcan Centaur separation successful.
And we've begun thermal loop conditioning on the RCS.
Staging ignition of the Centaur. Staging ignition and ignition of the Centaur upper stage and payload fairing jettison is confirmed. The vehicle is now weighing less than 10% of its liftoff mass.
RL10 continues to perform nominally. And we are partway through a 10.5-minute burn.
This is Vulcan Mission Control at T plus 6 minutes and 20 seconds. We just heard flight commentator Hannah Peters confirm the successful completion in approximately 10 minutes. While we wait, I'm now joined by ULA's Space Force Program Manager, Megan Lapine. Megan, thank you so much for being here today.
Thanks for having me, Andrea.
I think we're all really excited that we just saw Vulcan launch for the second time. I know a lot is going on with us this morning, but why don't you tell me what's going through your head right now?
Sure. So I think it was a beautiful liftoff this morning. I think we're all really excited to see that. It's such a significant launch in terms of our certification and where we're going with Vulcan. So it was just a tremendous accomplishment from this team. Really proud to be part of the team that did this. Not just the ULA team, but also our Space Force partners, our suppliers across the country. So many people put in so much hard work, so much effort, so much dedication into this, and it's an amazing thing to see this morning.
You never think about it, but there's so many different parts that go into a successful, even just getting off the pad.
Absolutely,
launch.
Yeah.
So why don't you tell us a little bit about the countdown?
Just another update. Then I'm making the volume up again. At T plus 7 minutes, a look at the first stage performance numbers showed a good burn by the Vulcan rocket.
The launch ops team here, the engineering team in Denver, very experienced and really able to, they have a good understanding of the vehicle systems, the ground systems, and we're able to kind of disposition those items and move forward. And we worked a little bit into that window and then got a nice sunrise launch. So
it was really beautiful. I didn't hate seeing the sunrise, not at all.
That was nice.
So we've talked a lot during the broadcast about how this is really important for certification, this launch today, and our government customers. Why don't you tell us a little bit about that?
Sure. Actually, before the launch today, we had a chance to talk to our colleague, Greg Novi. He put together a little description of how we get new launch vehicles certified for national security space. So why don't we take a look at that, and then we'll talk some more.
Great. Let's take a look.
Right now, T plus 8 minutes and 30 seconds. Update we got that velocity of the vehicle is over 10,000 miles per hour. The Centaur upper stage continues firing in its first burn, consuming liquid hydrogen and liquid oxygen propellants. The telemetry indicates good performance by the upper stage. T plus 9 minutes and 55 seconds. Powering the center upper stage in today's launch are the 528th and 529th production engines from the RL-10 family, and the second flight for the RL-10C-1-1A model, that is the newest and the higher performing variant of the venerable engine. For the past 60 years, Centaurs and the RL-10 engines has played a vital role in the placing humans of military, government and commercial satellites into Earth orbit, and has helped send spacecraft to explore every planet in our solar system. We are nearing to T plus 11 minutes. Velocity now exceeds 12,000 miles per hour.
Working shoulder to shoulder throughout the entire design, development, test. Build and now operations for Vulcan with the Space Force. So they've been our partner throughout that process, and we continue to provide information, share data. And then with this flight, once we complete the mission today, we will provide them that data and then continue to support their certification efforts.
Great, that's very exciting. Mm-hmm. So, you work with the Space Force pretty regularly, obviously. Yes. But what's next for the Space Force and ULA, and how is Vulcan a difference maker for the Space Force?
Sure. So once we get certification completed, that will allow us to be able to launch the national security space missions that we have on contract. So we have some, that we're getting close to being ready to launch, and we're really excited to focus on those and the mission success for those missions. And Vulcan generally was designed to meet the entire range of the national security space requirements. So it has the Centaur V upper stage. It's the highest performing stage in the world. And that's really a difference maker in terms of being able to meet those most critical orbit requirements, the most stringent accuracy requirements, the most challenging orbits, delivering the spacecraft to where they need to be when they need to be there. And that's important as we continue to partner with our customer as their requirements evolve. Will evolve and be able to deliver the capabilities they need. And we're looking forward to building that partnership and continuing it.
Great. I'm super excited for the future with Vulcan and the Space Force.
Me too.
Thank you so much for joining us, Megan.
Thanks,
I'll
Andrea.
let you get back to console.
All right.
Thank you so much.
Thanks.
Past T plus 12 minutes. At that point, the Vulcan rocket flew across the Atlantic Ocean and performance appeared nominal. Right now, we have less than 2 minutes remaining in this first Centaur
Just about 2
burn.
minutes to MECO, or to nominal MECO. Everything continues to perform nominally. The vehicle is now traveling at 14,500 miles per hour.
As you just heard, the velocity now exceeds 14,500 miles per hour. A check of Centaur telemetry showed nominal data as the upper stage continues in its initial burn to obtain orbit around the Earth.
And we're now approaching approximately 1 minute to nominal MECO. Everything continues to look good. Our Alton engine parameters are as expected. MPU is correcting as expected.
At T plus 15 minutes and 54 seconds nearly, we will be having the MECO 1, Centaur's first main engine cutoff in today's flight. Next we will have
MPU has come off its lock stop.
This is Vulcan Mission Control at T plus 15 minutes and 35 seconds. We're approaching the first main engine cutoff. Let's listen in.
Car is now orbital. MPU has gone to open loop. Coming up on MECO. And we have MECO, main engine cutoff 1.
This is Vulcan Mission Control at T plus 16 minutes and 22 seconds. We just heard flight commentator Hannah Peters confirm the successful cutoff of the main engine and all systems continue to operate nominally. Our next mission event, main engine start, will occur in about 15 minutes. While we wait, let's hear more about the Vulcan rocket from Mark Peller, ULA's Senior Vice President of Vulcan Development and Advanced Programs.
As we just heard from the COM as well as from Andrea, that at T plus 16 minutes and 15 seconds, the first main engine cutoff or the MECO 1 is confirmed for the Centaur upper stage. The Vulcan rocket has reached a preliminary Earth orbit where it will coast about next 15 minutes before the burn to achieve an Earth escape injection to the deep space. Nearly 14 minutes from now, we will be having not even 14. Yes, nearly 14 minutes from now, we will be having the Centaur's second main engine start. Second time during today's flight. The event also is known as MES2 at T plus 30 minutes and 53 seconds. And just 4 minutes after that, we will have the Centaur's second main engine cutoff. Second time during today's flight, that is MECO 2 at T plus 34 minutes and 54 seconds. Yes, they made really these looks are good. And as you said that how many cameras are there on the rocket, even that is my curiosity as well. And hopefully we could get all the views from them, but we are not provided with all the views from all the cams. But I guess we will be getting the onboard camera near the solid rocket boosters. They will be posting it, I guess. Last time they did. And welcome, Vlad. Thanks for tuning in. Hope you are doing well and you are doing well with your studies as well. You can wind back a little to have that launch to witness, Vlad. It just happened. Right now we are nearing to the end of flight profile today. The last trajectory on the screen you saw, that interplanetary, today that will be the flight profile for Vulcan.
This is Vulcan Mission Control at T plus 20 minutes and 43 seconds. Our next mission event, main engine start, occurs in about 10 minutes. We'll take a brief break in live commentary while we wait for that event. During the break, you'll continue to see the live flight animation powered by telemetry from the rocket as
So they can take a break, but I'm here. Well, in fact, was mentioning that Vulcan can provide service that to have the payload placed in Earth orbit, geosynchronous or Earth orbit, which is 35,786 kilometers circular at 0 degrees. Then it can place payload at geosynchronous transfer orbit, the same distance from Earth, that is 35,786 kilometers, but at 27 degrees. Also, it can place low Earth orbit reference payloads at low Earth orbit reference, which is 200 kilometer circular at 28.7 degrees. Also, the Vulcan can carry cargo or maybe in future a human space flight. I'm not sure about that, but according to their updates, they mentioned that they can reach to ISS, which is at low Earth orbit, at 407 kilometers circular at 51.6 degrees, placing payload at low Earth orbit polar, 200 kilometers circular at 90 degrees, medium Earth orbit as well, which is at 20,368 kilometers circular at 55 degrees. Additionally, it can place payloads in translunar injection. So it has nearly 7 kinds of orbits to target. So today's certification flight really is an important landmark in ULA's upcoming launches and contracts. Also, previously I was watching that they were supposed to have an USSF launch just after some days from today, but right now on those launch schedule sites, it is no more showing anymore. I guess that was supposed to be USSF 106, which will be the first mission for first national security mission for Vulcan Centaur using VC4S configuration, where it will have 4 solid rocket boosters and a standard fairing configuration. But I guess now they are targeting for this launch in November.
Vulcan Cert-2 flight. Joining you from ULA's Advanced Spaceflight Operations Center at Cape Canaveral Space Force Station in Florida. ULA's second Vulcan rocket lifted off at 7:25 a.m. and all systems continue to operate nominally. As we continue in second stage flight, let's hear from ULA's Director of Upgrades Development, Amanda Piketty, about the capability of ULA's venerable Centaur.
Centaur, the second stage for ULA's Vulcan rocket, was developed in the 1960s and continues to play a vital role in our nation's efforts in space.
That
Vulcan lifts off with the boost.
now the vehicle is halfway through this coast period. Centaur systems remain stable. A check of Centaur telemetry showed a good data. The vehicle continues in its predetermined course, heading to a precise point in space just off the African coast where the second engine firing is planned. I guess we are now five minutes away from the second main engine start for the Centaur, that is MES2, which will occur at T plus 30 minutes and 53 seconds.
On the LH2 and LO2 tanks.
This is Vulcan Mission Control at T plus 29 minutes and 49 seconds. We're about a minute away from the second main engine start. Let's go back to Hannah Peters.
And we have pre-start on LH2. And LO2 pre-start. And vehicles begun closed loop steering.
This is Vulcan Mission Control at T plus 31 minutes and 20 seconds. We just heard confirmation of second main engine start. While we wait for engine cutoff scheduled to occur in about 4 minutes, let's take a look at how our Vulcan booster stage is painted prior to departing ULA's Decatur, Alabama factory.
Actually, I would like to correct it that T plus 31 minutes and 10 seconds, the main engine start to ignition happened. The Centaur upper stage to RL10C-1-1A engines have ignited again to climb from its initial parking orbit into a Earth departure trajectory. At T plus 32 minutes, this 4-minute firing by Centaur upper stage, the second of burn during the launch of the second certification flight, is progressing well according to the telemetry. Each RL10C-1-1A engine on Centaur's upper stage is rated to 23,825 pounds, which is equivalent to 106 kilonewtons of thrust to propel the pressure stabilized stainless steel upper stage to its next planned orbit. Right now we are waiting for the final milestone in the webcast today, that is for the second main engine cutoff MECO 2, which will occur at T plus 34 minutes and 54 seconds, and we are nearly 1 minute away from that.
Approximately 1 minute to MECO.
"20 seconds into the burn remaining.
Approximately 30 seconds to MECO. And we have MECO, main engine cut off too. We're now venting the fuel tank. We have approximately 2 minutes and 49 seconds until simulated spacecraft separation. We have full settling on RCS, and the vehicle is now rolling to its simulated SV SEP attitude. And RCS is now doing 50% settling and thruster warming.
Right now you are seeing the RCS, that the reaction control systems, reorienting the Centaur's upper stage, on which the inert payload and inert payload is attached, which will be separated in a predetermined coordinate. So for that
Body
this
rates are trending
adjustment
towards zero
via
now. Coming up
RCS
on our
are
simulated
necessary,
spacecraft separation.
because all this although we are having an inert payload today, all this data will be required for the certification process. Following the evaluation of the data, the Vulcan, with fingers crossed, will be getting certified. Now we are waiting for the payload separation and inert payload separation.
Vehicle is now rolling, and we are depressurizing the LH2 tank. And we have simulated spacecraft separation. We now have an approximately 28-minute coast until the third burn. And vehicle has started its descent and is now pointing towards TDRS.
According to the comms, I guess the payload separation happened, but on the animation we didn't got to see yet.
Passing 40 minutes into flight, Centaur continues to look good throughout this coast period. All parameters are looking nominal. RCS is performing its periodic firing. And our body rates are trending towards 0.
This is Vulcan Mission Control at T plus 41 minutes and 50 seconds. We just heard flight commentator Hannah Peters confirm the successful completion of the beginning of today's flight. This completes today's mission coverage. I am now joined by ULA's CEO and President, Tori Bruno. Tori, thank you so much for being here with me today.
My pleasure.
I've worked on this program for a really long time. I am very excited to see the beautiful launch. I feel like we waited for the perfect moment to lift off. So I just want to say congratulations. It's just an incredible day.
Well, thank you, and you too.
Thank you. And thank you so much for being here. It's my understanding you want to tell us a little bit about today's flight?
Yeah, so the trajectory was nominal throughout. We came to our first insertion on the orbit that we intended, so all of that is good. We did, however, have an observation on SRB number 1, and so we will be off looking into that after the mission is complete. Other than that, the flight was nominal.
And you know, that's the great thing about these certification flights is it allows us to get more information as we get into our regular launch cadence, but you know, just a testament to Centaur and Booster on how beautiful that launch was so far.
It was a gorgeous liftoff, absolutely.
Great. So as we continue on with this launch, after the launch, we'll go through, look at the data and just make sure that we're certified for, you know, national security space missions. Why don't you tell us a little bit about what that certification means for ULA and the launch industry as a whole?
Yeah, certainly. Well, for ULA, we designed this rocket for the national security mission space. In completing the second certification flight successfully allows us to begin those missions that are urgent and important to the country. What it means overall for the industry is that we've introduced a new launch vehicle and a vehicle that is capable of launching at a pretty high tempo, and so we have broadened the entire country's capability for lift, and you will begin to see that launch tempo really tick up, especially next year.
I'm really looking forward to that. Who doesn't like a rocket launch?
Well, no one as far as I know.
I know, those people would be crazy. So I do want to say how hard it's been the past couple of years. Everybody has worked to get to this moment. I mean, this is kind of a pinnacle for us in terms of overall Vulcan development. Do you have anything to say to all of the folks that have worked on Vulcan over the years?
Absolutely. I just want to express my appreciation. Developing a new rocket is a monumental task. It is one of the pinnacles of engineering accomplishment. It truly is rocket science. Yes. Our team has worked so very hard over the last several years to design this rocket, to build it, to test it, to overcome the many technical challenges that are inherent to that. I could not be more proud of our team. Thank you all.
Thank you, seriously. This has been just so incredible to be a part of this team, and I don't think that there's anything I've been as proud of, besides my children, of course, to this moment. So now that we've launched, hopefully we'll get certification under our belts here shortly. What's next for Vulcan?
Well, we have a pair of national security missions in the pipeline. So we'll do those, and then we'll roll into next year with a whole number of flights.
Great. It's going to be an exciting year next year for sure.
Yes, it will.
Well, Tori, I know you have to get back, but thank you so much for joining us today. I am very excited about today's launch, and I always appreciate your time.
Oh, you bet. Thank you. You're doing a great job today.
Thank you so much.
All right.
Thank
Bye-bye.
you. Bye-bye.
So with that, we will be wrapping up our coverage for now. Be sure to check out our social media handle on X for the latest happenings in the space industry and updates on upcoming launches. Hope you enjoyed the stream, and let's pray for the positive outcome of today's mission launch and the certification of the Vulcan rocket, so that we can have more rocket launches of this remarkable rocket. Now we will be streaming the undocking and splashdown of the Crew 8 mission, as well as the OneWeb Launch 20 mission from Vandenberg. As of now, the undocking and the splashdown of the Crew 8 mission live streams are not there on our channel. We will be scheduling it within a couple of hours. Be sure to tune in. Wishing everyone a great week ahead. Thanks for watching. This is AstroYonder Live and me, Dipto, signing off for now. And we will see you next time.